A very good afternoon to you all. So I welcome you all to the session. So today we will discuss about the concept of geo computation. So we will actually here I am assuming that you already are familiar with the basic constructs of Python programming language. So I will not cover the basics of Python. So I will directly go to the geo computation part. So I will briefly discuss what is geo computation, and basically we will discuss about the raster data processing using Python. So actually geo computation is a larger topic. So today we will be just restricting ourselves to the raster data processing part of the geo computation. So if we start with geo computation, so what is geo computation basically? So geo computation is made of two terms. One we call geo, and another part is computation, right? So the geo follow certain set of given, if you just follow a certain set of instructions, and by just following those set of instructions, if you are about to reach some result without applying something specific, that what we call computation, right? So geocomputation is use of any computational methods to analyze, model and visualize geographic data. So it means applying these computational techniques to geographic data or any geospatial data is what is called geocomputation. Right. So as we said, that computation is just about following certain set of instructions, and computation is just applying certain set of instructions to reach some result. Like suppose if I ask you to multiply two numbers, right? So you will be applying certain algorithm, whatever you have learned. How do we multiply two numbers, right? So we don't apply any specific our skill set there. We just follow the set of instructions which we have learned earlier, like how do we multiply two numbers. So we just apply those set of steps whatever we have learned, and we get the result. So similar to this is like any problem that which can be solved by following certain set of instructions is called a computationally solvable problem. And so geocomputation is the application of these computational techniques to specifically to geospatial data. So that what is geocomputation is. So basically geocomputation integrates geography, computer science, statistics and mathematics. When we combine all these things, so in geocomputation we apply all these things together. So geography, with the help of geography we collect or say interpret geographical or geospatial data, and with the help of by applying these computer science concepts like algorithms, statistics and some basic mathematics, we do geocomputation. So basically geocomputation focuses on using algorithms and simulations rather than traditional manual analysis. So we will be focusing on developing or applying these algorithms and simulation in an automatic fashion. So we will not be doing any manual analysis. So that's what geocomputation is all about. So what are the key objectives of geocomputation? So why do we do geocomputation? So the basic objectives of geocomputations are to process and interpret large spatial data set. As we said that we will not be doing any traditional manual analysis. So the key objectives are when we have a huge amount of geospatial data which is impossible to process manually. So in those cases we apply our geocomputation techniques to process and interpret huge amount of spatial data sets, right? So which is manually impossible to be done. So then we can use geocomputations to model very complex geographic or geophysical processes as well. We can develop predictive and simulation based approaches. Also using geocomputation we can enhance spatial decision making and planning. So if you if you have to with the help of this geocomputation techniques we can enhance our spatial decision making as well as planning processes. So what are the core components of geocomputation? So the core components are of any geocomputation are spatial data handling. So the basic steps in spatial data handling is, first we need to collect geospatial data. Then once you collect the data, then we must have some models or techniques for storing and retrieving that data, right? So, spatial data handling is all about uh, finding a suitable model for representation of geospatial data, then managing that data. So, how do we store that data and how do we retrieve that data uh, efficiently? Then, cleaning of that data. Sometimes whatever data we collect from, maybe from the sensors or satellite sensor or ground-based sensors, so the data may contain noise, right? Noise or some invalid values maybe in that data. So cleaning that data so that the further down the line processing can be done easily is also one of the most important aspect of geocomputation, right? So spatial data handling, in the spatial data handling we will be discussing about how do we manage the data and how do we clean that geographic data or geospatial data, so that down the line processing tasks can easily consume that the data. So then modeling and simulation is also one of the core component of geocomputation. So it is used for representing real world processes computationally. So whatever real world processes we or real world physical phenomena which are taking place around us. So suppose if you want to simulate them or process them computationally, like so what we wanted to simulate those processes using a computer. So then these physical processes, we need some way to represent those computationally. So geocomputation helps us in that as well. So then by the if you see today, AI is the buzzword. So everybody is talking about artificial intelligence and machine learning, right? So now artificial intelligence applying different machine learning algorithms and AI algorithms also to spatial analysis also has become a core component of geocomputation. Like so, if you so now AI also has artificial intelligence techniques also are becoming a core component of geospatial analysis, like where it is not possible. Suppose if you don't have a clear cut solution for some specific problem at our hand. So in that case, like if you don't know the specific algorithm, then in that case we can use artificial intelligence AI techniques also in geocomputation as well. Now we can say that AI and machine learning are also becoming an integral part of the core are becoming the core component of geocomputations. Then we can use like high performance computing also has been, like suppose if you have to process huge amount of data, say gigabytes or petabytes of data. So in that case we need high performance computing also for processing those massive spatial data sets. Suppose if you are processing a small data set, then in that case you don't need high performance computing. But as the scale or size of your data grows, then you need high performance computing also. So if you have to do a large scale analysis, in that case this high performance computing also becomes a core component of your geocomputation part. Then once the data is processed, so you need some interact visualization of that data, right? So then interactive and three dimensional spatial displays of that result or data are also core components of geocomputation. So basically geospatial data geocomputation is basically focused on spatial data handling, modeling and simulation of different kinds, application of artificial intelligence algorithms, and high performance computing, and ultimately visualization, right? So in today's session, because we have just limited 1 hour session, we will be just focusing on very basic geocomputation analysis on, say, one or two sets of images. So same algorithms with the increasing complexity you can apply to a larger data set also quite easily. So what are the basic tools and technologies that people use in geocomputation, right? So basically, suppose if you don't want to write any program, so in that case you can use already available GIS softwares for your geocomputational tasks, right? Like doing any kind of spatial analysis. So there are different softwares available either in open source or commercial domain as well. So like these are the very common software. ArcGIS and QGIS are two very common software which generally people use for spatial analysis. Then if you are comfortable using programming language. So there are many programming languages also which support geospatial data processing or geocomputation. So Python is one of the most popular programming language for doing geocomputation. Apart from Python, it can be done in R or MATLAB as well. So once you choose any programming language, so then either you need to do everything from scratch. But if you see today you need not do anything from the scratch. There are many many communities worldwide are working on geospatial data sets. So they have built a lot of very powerful libraries for doing this geocomputation task or say geo processing. So there are very few libraries available, not few, actually a lot of libraries are available. So one of few of the most popular libraries for geocomputation or geospatial data analysis are, like suppose if you wish to do raster vector data processing, so GeoPandas is one very commonly used library. And suppose if you wish to do raster data processing, then raster.io or GDAL can be used. So GDAL supports both vector as well as raster data. Then there are some cloud-based platforms as well where also you can do the geocomputation, right? One of the most popular platform is Google Earth Engine. Right? So we will discussing about Google Earth Engine is tomorrow's lecture. So if you want to do the analysis, if you don't want to install anything on your local system, then you can use cloud-based services as well. Like Google Earth Engine is one of the most popular thing. Then there are, suppose if you wish to do some machine learning or artificial intelligence based analysis on your geospatial data. So there are two most popular frameworks for that. One is TensorFlow and another is PyTorch. So depending on your experience, you can choose either TensorFlow or PyTorch if you wish to do some artificial intelligence AI based analysis on your data. Right, so where all what are the applications of geocomputation? So as we said that geocomputation can be used in almost everywhere where geospatial data can be used. Like it can be used for environmental modeling, like deforestation modeling, deforestation monitoring, air quality prediction or modeling, climate change. So it can be used in urban planning for smart cities, transportation analysis, study of transportation systems. It can be used in disaster management where we can use it for flood and earthquake risk prediction and modeling. It can be used in agriculture for crop yield estimation, soil mapping, or any kind of application, public health, spatial disease tracking and modeling. So these are some applications where, so like wherever geospatial data can be used, and wherever you need to work on a huge data set efficiently, so everywhere you need to apply geocomputations in some or another way. Right, so in today's lecture we will just focus on raster data handling only. So we will just see how do we read raster data using Python's using Python programming language, and then we will do some basic analysis on that raster images, like calculating different indexes like NDVI, NDWI, or so, right. So what is raster data? So as we have, I think this must have been discussed in your previous lectures. So raster data represents objects or variables on the earth, on the surface of the earth, or the near to the surface of the earth, right? So raster data represents object or phenomena or variables on the earth's surface as a matrix of values. So any phenomena that is taking place on the surface of earth or near to the surface of earth is represented as a matrix of values. So the raster data can be values in the form of pixels, cells, or grids. So the raster data, so anything can be represented, like the image of the earth can be represented as a raster. Or suppose if you are monitoring the temperature at the different places around the earth, so that also can be represented. Or the elevation, ground elevation of the earth at different places also can be represented as a matrix of values, right? So so simple example is an satellite image. So a raster image can have multiple layers or bands. A raster image with a matrix of values representing the values of some observed attributes, right? So as we said that raster is an image with a matrix of values that are representing values representing the so raster is an image with matrix of values. So those values are representing some observed attribute. So it may be energy reflected in some particular electromagnetic uh, EM band at some particular EM wavelength also, or it may be a temperature, or it may be the value might be an maybe elevation as well, right? So bands of a raster corresponds to different variables. So a raster image can have single band or it can have multiple bands. So every band will represent some different information of different variables. So different if a raster image, if you are talking about satellite image, so satellite image can have 3 or 4 bands. So every layer or band will represent the image of Earth in different at different wavelength. Maybe one band might be representing the image of Earth in say red band, another maybe in green, and another maybe in blue. Or suppose if it is an temperature, so the temperature may be at different time intervals. Like one layer or one band might be representing the temperature of Earth at time t0, and second layer might be representing the temperature at say time t1, t2, or t3. Right. So as we say, so as we discussed, so now the raster image can have single or more number of bands. So all, if there are more than one bands in an image, so those all bands will represent different variables. So that variables may be depending on what kind of image it is. Like if it is a satellite image, so the every variable might be a different band, red, green, or blue. Or suppose it is a temporal information, say say rainfall or temperature. So it might be every band might be representing at rainfall or temperature at different time instances. So this is a typical example of a raster image. So if you see a raster image, the image looks like this. If you zoom into this area, so this entire area is represented as pixels or cells of small values, right? So if you zoom in, so the every cell in this image or pixel will be holding some value. So that value may be reflectance in some particular wavelength, or it might be temperature, rainfall, or anything. The value could be anything. So so depending on that intensity, the color of this cell will be drawn on the scale. So as we said that some rasters might have single band of data, some others might have multiple bands of data. Basically, band is represented by a single matrix of cell values, and raster with multiple bands contains multiple spatially coincidence matrices of cells. Right. So values representing the same. So all bands will be representing the same geospatial same geographic area, but that might be in different different electromagnetic wavelength, or it might be at different time instance, right? So say if you talk about single band raster can be represented in multiple ways. So single band can be a binary image where there will be only two values like zeros and ones. So this is what we call a binary image, or it could be a grayscale image where there will be multiple grayscale levels. Suppose if you are representing the pixel intensity by 8-bit integer, so then there can be 256 different shades of gray, right? So that you will call grayscale image. Or it can be, suppose if you have a classified image, so that single band can be a classified image also, where we can use a color map to display the image. Like all pixels with value 1 might be represented with a yellow color, so that may be representing a forested area. So all cell with values with 2, so that might be some water body, so that 2 may be water body, and so on. So single band raster can be a binary image, grayscale image, or a classified map. Then multi-band raster, a satellite image, for example, commonly has multiple bands representing different wavelengths from maybe ultraviolet through visible and infrared portions of the electromagnetic spectrum. So if you are talking about satellite image, so it can have multiple bands, maybe red, green, and blue. When we combine all these three, like for visualization, if you combine three bands, red, green, and blue, then with the combining three bands, we get a color composite or colored image, right? So when you combine three different bands, maybe R, G, and B, then we get a colored image. So this was all about the theoretical part of raster data processing. So for doing geocomputation on these raster images, I will be using a specific library called GDAL. So GDAL stands for Geospatial Data Abstraction Library. It is a translator, a library for raster as well as vector geospatial data formats. So we can say that GDAL is a computer software library for reading and writing raster as well as vector data. So whenever so GDAL so actually GDAL is one of the most versatile and popular libraries. So GDAL supports almost all raster as well as vector data formats, right? So actually what happens, all the raster formats or vector formats will differ from each other in multiple ways. Like some formats may use compression, some format may not use compressions, some format may be band wise interleaved, some maybe pixel wise interleaved, right? So depending on, so whenever you read an image using GDAL, so an image is represented using an abstract data model, that is called data set. So irrespective of the underlying format, any raster is represented in GDAL using something called a data set. So that data set will in turn will have multiple functions available which we can use them. So right, so GDAL also comes with a variety of useful command line utilities for data translation and processing. If you are not comfortable using programming language, then it has some command line utilities as well. So with those command line utilities also you can use for geocomputation or doing some kind of processing on raster as well as vector data using GDAL. So what are the advantages of using GDAL? So it is free and open source. You need not pay anything for it. It supports over 80 plus image formats and more map projections. So almost all raster as well as vector formats you can read and write using GDAL, and all map projections also it supports. Then it has command line as well as APIs in C, C++, Python, R and Java programming language also. It is used extensively by world's large geospatial data services. A lot of geospatial data services provider are also using on backend GDAL only. Plus it has an extensive test suite and active developer community which are constantly contributing to the development of GDAL. Plus GDAL has an exclusive intensive support for vector data set as well. Like you can use it for both vector as well as raster data processing as well. As we said that this is then so a model is an abstract representation of something, right? So in GDAL, as we discuss, because there are raster data comes in multiple formats. So in case of GDAL, if you read any image using GDAL, so any raster image in GDAL is represented as an abstract model or an abstract class called data set. So irrespective of any format, either you read GeoTIFF, IMG, JPEG 2000, NV image or any image, whatever image you read using GDAL, so that image will be represented by an object called data set, right? So it is an abstract representation of an image, and irrespective of the format, every image will be represented in GDAL using something called data set. Now depending on number of bands available in your image, every data set object will contain multiple band objects in that, right? So if it is single band image, it will contain single band object. That data set will contain single object called band 1. Or if it has multiple bands, then all bands will be represented by different band objects. Plus it will contain some additional information, geo transformation and projection information, so that the image can be projected on the map. So in every band in turn will contain the data. As we said that like image is a cell of or a grid of cells, like, and every cell contains some value. So that values are represented using something called data array. Plus it will have some overview bands or reduced resolution data sets also attached to that band. So if you are zooming in or zooming out, so at depending on that zoom level, that particular overview band will be projected, right? So irrespective of the data format, every raster image using GDAL represents every raster image as something as an object called data set, and that data set will in turn will contain band, and band will contain data array and other things. Right. So here I am using Google Colab. Otherwise, suppose if you use Google Colab, so everything comes here pre-installed. You need not install anything on your anything. So most of the libraries are already pre-installed. Suppose if you wish to use it on your system, on your own system, then you can use Conda for installing GDAL to your local system. You can use any distribution of Python. Maybe Anaconda Python is the one of the most popular thing for data science among data science community. So either you can use Anaconda or Miniconda for installing GDAL on your system. So if you don't want to install anything on your local system, then you can use this Google Colab, right? So once you install GDAL to your system, then the package name of the package what you install GDAL is the OSGeo. So here I am just importing the GDAL for GDAL to my Python interpreter. So OSGeo, so GDAL I am importing for reading raster image, and matplotlib I will be using for displaying the image. And suppose if you wish to do some processing on that image, because the image is represented as numpy array, so we can import numpy array as well. And these are other things are not so important for this session. So math and other things, if you wish to do any processing or other things. So here what has happened, I have stored all my data in my Google Drive. So for using Google Drive, first you need to mount the Google Drive to your Google Colab. So drive.mount. So this will be just mounting then you give, it asks for the necessary permissions. Then if you need to give first the permissions. So once the drive is mounted, it will be shown as a folder here. So inside folder, my drive. And inside this, I have created a folder called DLP_data. So inside this, I have just saved a file called haridwar.tif. So that is an image from LIS-3 sensor of ISRO's ResourceSat-2 spacecraft. So it contains LIS-3 or LIS-4. It contains 3 bands: red, green, and NIR. So now let us see how do we read this particular image haridwar.tif using GDAL and visualize that particular image. So first thing what I am doing here, I am just changing my working directory to the directory where my data is available. If I don't do that, what I need to all the time I need to pass the full path of my file, right? So for this I am just changing my working directory to the directory where my data is available. Then next I am just creating a variable called file_name, and I am just storing in that the name of file which I want to read. Right. So anyway, already we have imported GDAL to our environment. So I just wanted to clear the outputs. So suppose if you want to fetch some basic information about the image which you wish to read or process, right? So for that in GDAL there is a method called info. If you call GDAL.info, and it passes 2 arguments. One is the name of your file and another one is the format in which you wish to retrieve that information, right? So I am passing here 2 arguments to the GDAL.info function. One is the name of file which is haridwar.tif, and the format in which I want my output. So and then I am collecting in something called in a variable called raster_info. So it reads all information about the image and populates the raster info dictionary, right? So now if I just print this raster info, you can see that this is the all information about our raster image in a nice format. So if you see that this is the information about our image like band. So this particular image contains band 1, band 2, and band 3. So that this particular image is a multi-band raster with 3 bands. So now this is the specific information about band 1. So band value is band 1, and this is the block size. So every block in the image is stored in 2000 cross 1 block size, right? So color interpretation, the interpretation of that particular band is gray color. So the maximum pixel intensity in band 1 is 231, and mean intensity of the all pixels in that band is 58.31, and this is another metadata like max, mean, standard deviation, then valid percentile. So all pixels in an image are valid. No, there is no invalid pixel in an image. Like this, these are the different overviews. So overviews are available at 1000 cross 1000, 5000 cross 500 cross 500, 250 cross 250. Right. So our native pixel image size is 2K by 2K, and these are the different the coarser resolutions. The same image is available as 1K cross 1K. So the pixel size is just increasing, means the resolution is decreasing, and similar way the information about other bands is available. And this is the projection information of the image. The image is stored in a projected coordinate system. So the projected coordinate system of the coordinate system of the image is UTM-44 North, which is based on WGS-84, and this you can read about more about this. These are the these are the corner coordinates of our image. Like these are the extents of our image. These are the geographic extents of our image. This is the coordinates of the center pixel. These are the coordinates of all four corners of our image. Like the format of the image is a GeoTIFF, and this is the geo transformation information. Like these are the this value, and these values are the latitude and longitude of our 00 pixels, and this is the resolution in x direction, 5 meters in x direction, and similar way 5 meters in y direction, and the rotation is 0 degree. So it means the north is directly up in our image, means the image is not at all rotated, so it can be directly projected on the map as well. And there is one metadata called area or point. So it means every pixel in our image represents an area. So it is an average value for the area of 5 meter by 5 meter. It is not an point data. So it means that the every pixel in our image is representing an area. Then similarly these are other information about an image, maybe some constant conversion factors, and like how do we convert from radiance to reflectance, and other values will be there in this data. Right, so the other projection information, all this. So just by using GDAL.info, you can extract basic information about your image before processing the data further. Now, similar thing, suppose if you want to do it using GDAL's open method, so there we are just called the info method, and that just fetch the entire structure of our image. Now, suppose if you want to do it using Python code, so then you can. So first before reading, first we need to open the file for reading, right? So the function available for reading the file is in GDAL is GDAL.open, and you need to pass it the name of file which you want to read. So I call GDAL.open and pass it the name of file. So then that will return us a data set object. So that we are storing in a variable called ds, and if I just print it, you can say that this is the osgeo.gdal.dataset. As we said that this is the basic GDAL's raster data model. So irrespective of the underlying format of the image, all images are represented as an object called dataset. That you can see right now here. So we just called GDAL.open and pass it the file name, and it has returned us an object called GDAL.dataset. Right. So now in this object, multiple functions are available. With the help of those functions, you can get information about your raster. Right. So suppose if you want to get the list of files, like what file name you had read. So there is a function called get file list. So if you call ds.get file list, it will return you all the files which are associated with this image. Like haridwar.tif is the image, and there is one associated XML file also attached to that, haridwar.tif.xml, or if there are some RRD's image also attached to that image, so those also will be listed here. Now next thing, the natural thing, after knowing the name of file, you wish to query like how many pixels, what is the size of your image, like how many pixels are there in x direction, or how many pixels are there in width, and what is the height of your image. So the functions are available, attributes, sorry, not the functions. So ds.rasterXsize returns you the number of pixels in x direction. Similarly, if you wish to, so it's written 2K. Similarly, ds.rasterYsize returns you the number of pixels in y direction. So our image is 2000 cross 2000. So similarly, if you want to get the projection, fetch the projection information, you can call ds.getProjection. So ds.getProjection returns us the projection information about our image as it was written by GDAL.info. So it says that the image is stored in projected coordinate system, that is UTM-44N. This is based on geographic coordinate system called WGS-84, and these are the other parameters of the projection system. And similar way, suppose if you wish to get the geo transformation information, like the information affine transformation information of the image. So with the help of these affine transformation parameters, you can project your image on the map. Right. So these are the parameters, like any affine transformation, as you know, are six element list. So first parameter represents the longitude of 0th pixel. Then this is the resolution in x direction. Then this is the rotation. If image is rotated, if any pixel is rotated, you will see some value here. If it is 0, means there is no rotation on any pixel on anywhere. This is the latitude of the 0th pixel, and this is the rotation in y direction, and this is the resolution in y direction. Right. So this is the same thing. Now with this help of this geo transformation information, you can you can calculate any coordinate of any pixel. So in an image coordinate system, any pixel is identified by its line number and pixel number, right? So suppose if you wish to convert them to the real world coordinate on the Earth surface, then you can apply this function called GDAL.apply geotransform and pass it three arguments. One is your geotransformation information which we have extracted, and line number on pixel number of image or a line number on pixel number of your pixel for which you want to calculate the real world coordinates, right? So if you see the top left corner of our image, so that will have coordinates pixel number and line number as 0 zeros. Similar way, the right corner will have whatever is the width of our image, and y will be 0 0. So similar way for other corners of our image. So if you apply this, so we can see here that we are getting the coordinates or extent coordinates of our four corners of our image and the center pixel of our image. Then similarly, if you wish to fetch any additional metadata from your image, because generally what happens when the producers of the geospatial data, they attach some metadata also to the image so that the user or consumer can use it for further processing or interpretation of that data. So that metadata can be fetched using a function called ds.getMetadata. So only one metadata is attached here, area or point. So it is representing an area. So suppose if you wish to get how many bands are in your image, so then you can call the function ds.raster count. It returns how many bands are available in your image. So it is returning 3. So similar to the GDAL.info, suppose if you wish to calculate the basic statistics on all of these bands and get the color interpretation of each band, or how many overviews are attached to each band as well. So that also can be done in a loop. Here we are starting a loop starting from 1, because generally in computer science indexes start with 0, but in case of GDAL they are starting the indexes with 1. So we are starting, so here so in the loop also we are starting from 1 to number of raster bands available in our image. So ds.get raster band is a function available in our dataset that fetches a particular band, whatever number you pass to it. So it will fetch that particular band object. So in that band object you can get color interpretation, the name of that color interpretation, and how many overviews are attached to that band, and any other information. Right. So like this is the basic information about all these bands. So similar way, suppose if you wish to calculate some all statistics on each of these bands, like what is the minimum pixel intensity in that particular band, what is the maximum intensity, what is the standard deviation across those bands, right? So then there is a function called band.compute statistics. So band.compute statistics, so you pass it the band object, and it will compute all statistics, mean, max, min, and standard deviation across the entire band. So then we are just passing it an argument called approx OK. Like, are you okay with the approximation, or you want or you want the statistics to be calculated on the native resolution. So suppose if you wish to calculate the statistics on the native resolution, then we will passing the approx OK is equal to false. Right. So now I am iterating over all these bands one by one. Actually, I missed this step. So like here you can say that this is the information about the band 1. Band 1 has minimum pixel intensity as 40, max as 231, and this is the mean, and this is the standard deviation across all the pixels. Right. So this is about computing statistics. Now, as we had discussed in the previous part of this lecture, that every image is represented as a matrix of or grid of cell values, right? So now suppose if you wish to see the data like pixel intensity, how does it look like? So first thing, anyway, we have already read the image using gdal.open. Now, just suppose if you wish to read band 1 and see how does those pixel intensities look like in our image. So first thing, from the data set, I am just fetching band 1. So ds.get raster band, and I am just fetching band 1 object from my data set. Now in that band object, there is a function available called read as array. So read as array will return us a numpy array representing pixel values for intensity values for all pixel in our image. Right, so if I see data and if I just print data, now here you can see the image contains these values. So because of performance reason, NumPy doesn't show entire 2k by 2k array, so it has just shown you some initial top initial edge values only. So because of performance reason, right. So these are the pixel value, like 00 pixel has intensity 51, first pixel has 51, 52, like these are the different values, and this was the statistics. Now suppose if you wish to visualize this, for visualization we can use matplotlib. So matplotlib has a function called imshow. So to imshow we need to just pass our numpy array. So if I pass the numpy array, we can see this is the our actual grayscale image. So then you can, suppose if you wish to see all bands together, you can use matplotlib's subplot function as well. So this you can see all of bands together as well, like so. So this is band 1, band 2, and band 3. So like this you can visualize all bands together as well using matplotlib. So now the next task is how do we, as we said that an image can have multiple bands. So these are, we are seeing these all bands individually, right? So suppose if you wish to visualize a multi-band raster, so there are many possible combinations, as we said that. So you must be knowing already that for seeing any colored image, we need 3 primary colors, right? Red, green, and blue. So for visualization, if our image has say 6 or 7 bands, so out of these 6 or 7 bands, any band we can visualize as a red color, and any other band we can visualize as gray color, or green color, and any third band we can visualize as blue color. So by combining these, we can create different kinds of color composites. So these are called false color composites, right? So depending on some particular feature which you are interested, depending on that, we choose different color combination that I think you must have studied in your remote sensing classes lectures as well. Right, so out of these 6 or 7 bands, we, depending on our application, we can represent any any band or any wavelength using a red, green, or blue. By combining these, we can create different kinds of color composites. That what we call false color composites. Right. So they, like, one of the most popular thing is what we call standard false color composites, where near infrared band we represent as a red color, and green wavelength we represent as blue color, and red we represent as green color. So this is one of the standard false color composites. Apart from this, there are other different false color composite combinations. So let us see how do we create a false color composite. How do we create a false color composite using GDAL, right? So previously, what we were doing, so once we opened an raster image, we were getting a data set. So in data set, there are multiple functions. There is another function available on GDAL data set object, that is called read as array. So read as array. So if you call in your data set ds.read as array function, and you pass it the list of bands which you want to read. Suppose if I want to read band 3, band 2, and band 1. So in my original image, band 3 represents NIR, band 2 was red, and band 1 was green. Suppose if I wish to read only these 3 bands from my image and this order, so I ds.read as array and pass it the list of bands which I wish to read. Right, so it will be reading, it has read 3 bands, right? So now for actually this format is what we call HWC format. But for displaying it on the image, actually we need it HWC format. So this is CWH format. So for representing that image, for visualizing that image, we need the data in HWC format. So for that we are using the function in NumPy. There is a function called np.transpose. So with that we are just converting from CWH to HWC format. So with this transpose, you can just convert into HWC format, and just now we will be using the same function called plt.imshow to visualize it as an in colored band. Right now, so previously we were just visualizing a single band or grayscale image. Now by same matplot.imshow function, just by converting the format from CWH to HWC format, we can visualize an multi-band image. So similar to this, you can create any other kind of another false color composite as well. Like suppose if you wish to show a band 2 in red and band 3 in green and band 1 in blue, right? So now you just change our reading part. So now I have just changed the sequence of band list in my reading part only, and visualization part remains same only. Now you can see that the same image when we visualize this in different band combination looks like this. So this way you can create any false color composite using JIDA, right? So similar to this, there is another false color composite that we have created, right? So now you can see that the same band, just by changing their by representing different band in red, green, or blue channel, we can create different kinds of false color composites depending on, so certain features will be more prominent in certain band combinations. So depending on your application, you will be choosing these band combinations. So this was all about reading an image and visualizing an image. So we have not done any analysis or so we have just done the visualization part of geo computation in on our images, right? Now suppose if you wish to do some analysis on an image, right? So one of the most important analysis what we do an image is called local analysis. So local analysis or pixel wise analysis is called an analysis where we apply certain mathematical or algebraic operation on every pixel of our image, right? So that is what is called local analysis. So when we apply certain mathematical operation on every pixel on our image, that is called local analysis on an image. So one common task using spectral imagery is to compute various indices for indices for tasks such as maybe for distinguishing between burned and unburned area, or vegetation and non-vegetation, or identifying water and non-water, right? So calculating indexes is one very common task in remote sensing, remote sensing community, remote sensing application, right? So in when we calculate indexes, so we apply certain mathematical operations on every pixel on our image, right? One of the common example is suppose so for measuring the greenness we use something called normalized difference vegetation index, or NDVI. So that's a certain mathematical formula we apply on every pixel on our image. So NDVI is a simpler index that uses red and near infrared wavelengths to produce a number that ranges from -1 to 1. So we apply certain mathematical operation on two bands, red and NIR on every pixel on our image. Like if you apply that formula on every pixel on our image, we get a value that ranges from -1 to +1. That what we call NDVI of that pixel. So if the value is above 0.5 or 0.6, like 0.6, that we can say that it represents the greenness. So we can say that the image, that pixel is greener, so that might represent an vegetation. Or if the values are in the lower side, so that means that is less green, or we can say that this is non-vegetation part, right? So growing plants use red wavelengths for photosynthesis, but they reflect in near infrared radiation. So high ratio of these two measurements can indicate that will indicate some photosynthetic activity. So if you see in NDVI values, higher values, say 0.5, 0.6, that we can say there is some photosynthesis taking place. So that may be a vegetation part, right? So this is the formula for calculating NDVI. So NDVI we will be doing for calculating for every pixel on our image. So for every pixel on our image, we will this is the formula NIR minus red. So pixel intensity in NIR minus pixel intensity in red. If we divide that again by NIR plus red, we get the NDVI for that pixel. Now same operation if you do for every pixel on our image, we get the in an entire and get NDVI image for our entire NDVI for our entire image, right? So now we'll be doing the same thing. So now again, I am just reading the image haridwar.tif. So in my image, red band is represented in band 2, right? So I am just calling ds dot get raster band 2, so that I am storing in variable called red band. And similarly, NIR is in band 3, so I am storing that in NIR band variable. So suppose if I just inspect these the values, so the data type of these pixel intensities is unsigned 16-bit. Actually, you can see that these values are represented in an unsigned 16-bit integer. So if I apply any operation on unsigned integers, so what happens? The result also will be an unsigned integer only. But what happens, because we are applying the formula NIR minus red divided by NIR plus red. So sometimes the value of NIR minus red might be negative as well. But negative values cannot be represented in unsigned integers. So for that, I am just converting the data types of my pixel intensities from unsigned 16-bit integer to floating point numbers only by just multiplying that by 1 point. So this is only the purpose here, just for just converting the data type, or you can just apply .as type function as well. So either both are equivalent only. So I am just applying that 1 point. So all pixel intensities now will be converted to a floating point number, so that I can apply NIR minus red formula quite easily. So this is a number. Now you can see that earlier it was an integer number, now it is a floating point number. Right, now I have two arrays, one numpy array representing a red image, another numpy array representing NIR pixel intensity. Like if you are comfortable or know about numpy array, so now I need to just plug in this, like apply just this formula NIR minus red divide by NIR plus red. So it will apply this formula on every pixel on our image, right? So then it will give an NDVI array, right? So this is an NDVI array containing the values from -1 to 1. Now if I just display that with using the same function plt.im, so I get an NDVI image, right? So here you can see that all areas which are shown, which are bright, are the vegetation pixels, or the pixels they are green, and the pixels which are darker, so there is no vegetation, or they don't have green color. Basically, you can say there is no photosynthesis is taking place in these areas. Like this way you can create an NDVI. So with this you can calculate how many pixels are in vegetation area. Like suppose if you want to calculate the area of forest in your image. So this is an elementary way of doing that, right? So here anyway you have identified all pixels which have NDVI. Now you can filter all the pixels which have NDVI greater than certain threshold, and just count how many such pixels are there, and you know already how much area each pixel is representing. If you just multiply that, you get the area of vegetation in your image, right? So similarly, there is another index called NDWI. So the formula for NDWI that is used for basically for identifying water pixels in your image. So NDWI can be calculated using green minus NIR divided by green plus NIR. So here I am doing same thing, only a green band is in my band 1. So only difference is here green band I am reading in DS, green band I am band 1 I am storing in a variable called green band. NIR is similar only. Again I am just multiplying them with 1.0, so to convert them from unsigned integer to floating point numbers. Then finally I am applying the formula NDWI, green minus NIR divided by green plus NIR, right? Now suppose if I just visualize the NDWI image, now you can see that, so all the water pixels now have become brighter, right? So all the pixels which has NDWI value greater than 0, or say 0.01 or 0.2 are the water pixels, right? Now suppose if you wish to mask all non-water pixels from your image, right? So in NumPy there is a function called np.var, but before doing that you need to choose a threshold, right? All the pixels value above this threshold are only water pixels, right? So this is the manual process. Otherwise you can apply some different threshold detection algorithms are there, like Otsu thresholding and Otsu thresholding. You can that also you can apply for converting your image to a binary image. Like so here, and suppose if I am interested only in extracting the water pixels from my image, right? So I can just call np.where, and I suppose by some analysis or by visualizing the image, I have chosen like all the pixels which have greater than ndwi of zero point 0.08 are only water pixels. So I just want to just retrieve only those pixels and mask all other pixels. So there is a function called np.where ndwi greater than zero point 0.08. So wherever ndwi is greater than zero point 0.8, I am just changing that value to 255, otherwise 0. So this with this I get a water image. Now if I plot this, so now you can see that all the only water pixels have are shown here. So with this, I have converted the NDWI image to a binary image where only my water pixels are present on and everything else is masked. Right. So with this we come to the end of lecture. So in geocomputation, as we discussed that visualization and some spatial processing are the core part of geocomputation. So we have just briefly discussed about two aspects of this. One is visualization, and later on then we have done some basic elementary analysis on our images also, but which these are the two very oftenly used operations in remote sensing application, where NDWI and NDVI calculations. So with that, I come to the end of my lecture. So thank you very much for attending. If you have any lectures, if you have any questions, you can please post it on the chat box. We will try to answer as much as possible. So thank you very much.
Good afternoon to all of you. So today we have come to the fourth lecture of this module, that is basically introduction to the WebGIS technology. So here the two terms are integrating together, like GIS and the web technologies. So how that GIS components or the work which you perform over the GIS, how it can be integrated into the web environment. So we can say that that the integration of web and GIS together, they makes up the total concept of web GIS. Okay, so the content of this session will be like that. We will be starting from the client server architecture, because whenever we talk about the web GIS, we are basically talking about a client and a server architecture. Client means any user, suppose I am a user and I am trying to access a website through a web browser, let us say Chrome or Mozilla Firefox or Microsoft Edge, any web browser through that. So that is a client basically. And if I am able to access some data which is available over some another computer or another server, like let us say Google or the IRS website, or it can be an ISRO website, any website is there. So from there I am accessing the information, so that ISRO or IRS or Google, anybody, they become the server, whereas I am as a client. Okay, so how this architecture is set up, that we will be talking, and then we will be coming to the concept of to the definition of WebGIS, and how the architecture of WebGIS is built. And there are different kinds of architecture. One very popular architecture is related to the monolithic architecture and the service oriented architecture. You will be knowing about that. Monolithic means mono, means all the things are there in the single computer. Your database is there, your server, your application is over there, and clients are accessing those data sets and the functionalities through one single computer only. Whereas if I can access the data from multiple sources as a service, we can say. I will be talking more about this web services also. What do we mean by a web service? Okay, web service. So later on I will come to that part also. So it means like I am accessing the GIS functionalities or the GIS database from multiple sources. We can say from a distributed sources. In that case, it goes somewhere to this service oriented architecture. If I am accessing only from a single source, then it goes like, and all the data and the functionalities are stored in a single computer on a single server. So they comes into the monolithic architecture. But we can, the latest one are the service oriented architecture, where I am accessing the data from multiple sources for my use. We have an example also of service oriented architecture. This is the most popular one, which is being used these days for the GIS functionalities. And similarly, what are the various components of GIS we'll be talking. We will also talk about the geospatial web services. Although I was talking about a service oriented architecture, now how these are converted into a web service, the GIS data. So that also we will try to see. There is something called Open Geospatial Consortium. That is a very global agency which is making the standards for these GIS data to be converted into a web service. So there are certain data standards like WMS, Web Map Services, Web Feature Services. We will be talking about these things also. Although in my previous lecture I was referring to these standards, but today we will see what are the various features available with these functionalities. Although they are very detailed topics are there, but here in this lecture we will be covering only an overview of these features, of this standard basically, and what are the various data formats basically. In GIS we might have seen different formats, like save file is there, or a TIFF file or GeoTIFF file. Sometimes we are saying .img file. So when we go into the GIS format, these data, they are in different format like GeoJSON, XML, or there is something web compatible TIFF files are also there. So their different formats are also there. So similarly, we will see one use case of WebGIS. It can be a ISRO Bhuvan Geo portal. Already we have seen it day before yesterday. We can also talk about OpenStreetMap. There is another portal which we have developed at IRS, that is related to the forest, one application software basically. So that I will be showing you how we have used that service oriented architecture into that WebGIS portal over here. Okay, so moving further, if we talk the client server architecture, you can just say about simplest one is that there are different client. Now this client is making a request to a server. Okay, it can be through a browser basically. Whatever request I make to a server, that all requests primarily they are made through a web browser only. You type it in your Chrome. You are just typing www.irs.gov.in, or you are typing www.bhuvan.nrsc.gov.in. So in that sense, you are making a request to the server. So your Bhuvan or IRS, these two are the servers which are situated at this end over here, in the server end. And once the request is received by the server, it processes it and it gives you back the response in the form of an HTML page. Okay, so that page is displayed in again in your same browser only. So browser is your main primary interface which makes a request and receives the request from the server. So this is very primary architecture of a client server architecture, we can say. Now if we say about the secured client server architecture, so what we do here, we make a request, something called HTTPS request, that is hypertext transfer protocol, and S is for secured, means that whatever request you are making, that requests are not going as a plain text, they are going as an encrypted text. Okay, and so that it cannot be hacked in between somewhere. Somebody is trying to get that request from some unknown sources. So if you send it to a secured protocol, then it goes properly to the to the server. Okay, and this server, it basically it is ensuring the security of not only of the client but the security of the server also. So these days you might have seen that most of the websites, they are in this HTTPS protocol only, that is extra S is written there, and similarly the responses are also through the same protocol. Now in between, once these requests reach to the server, so direct request we are not receiving here. What we do, we put a a firewall kind of thing over here. Okay, web access firewall, WAF. Now the whatever request from different clients that is coming up over here, that goes to this WAF, and in the WAF we have written certain rules. All those rules are written in an XML format, and these XML format rules will filter out those requests, and whichever request is in order, which is the proper request, only that request are forwarded to the server. Otherwise some malicious request, they are dropped at this end itself. Now how to create, how to know that which is a malicious request and which is a valid request? So here we also have a database of, there are certain requests which have been labeled as a blacklisted URLs or the blacklisted request. So all those requests, it is a database is maintained, and that data, from that database only this XML fetches those requests and match it with the new request. If it goes proper, then only it is sent further, otherwise it is dropped at the firewall itself. So that database and these rules, they play a major important role in ensuring the security of the server, or and at the same time the security of the client as well. So these are the mandatory requirements that are being maintained these days. Similarly, now inside the server, what happens basically inside the, when I was talking to about only client, I was telling there is a firewall, and then I was saying about the server. Now what happens inside the server? Inside the server, this is a web client, it can be a browser, then there is a internet, then there is a firewall, then there is a small load balancer also. Suppose thousands of requests are coming, then balancing of the load need to be performed. That is done by one small component over here, that is called as a load balancer. And then inside that server machine, there are different components, like we have one web server. Web server is nothing but just a software which is installed in one of the hardware. Okay, and this web server is capable of understanding the requests which are coming in the form of HTTPS protocols. Okay, those requests it will understand, and if those requests are genuine in nature, it will provide a response to those requests back to the client. After that, now there are certain applications also which are inside the server, which creates those, suppose there is some specific request which requires some other resources from the server end, like database access, it can be access to a certain file also. I want to see a certain file, I want to authenticate the users with the help of a username and passwords. They all are stored in this database, and files, photographs, all those things are stored in the file server. So what happens, this application server will fetch those information from file and the database, and once this application server processes those data, it will give it to the web server, and then web server will only pass it on to the clients. So this way the complete architecture goes on inside the server. Now apart from that, there are certain admin panels also. for the administrative works, and the internal client applications are also installed over here, which also helps this application server in creating those requests, or the response to those requests basically, and they all are connected through a internal network here. Now I was talking about the first component inside the server was a web server basically. So web server, if we talk about, it is a software and hardware both that uses the HTTP hypertext transfer protocol and other protocol to respond to the client request made over the World Wide Web, or the www. Okay, from there requests are coming through this HTTPS protocol, and this server or this software is able to receive it and understand those requests and then provide the response accordingly. So that is, you can understand it, it is a server as well as a hardware, both. Okay, some of the common top web server softwares are like, it can be an Apache HTTP server. It is free and open source, most widely used software which you can install in any of the computer. Then apart from that, if you have a Java based application, then we have Apache Tomcat server. This is also free and open source, that also requires, suppose your application is built in some Java platform, and then this particular software, this particular web server is most preferred at that time, although there are others also. And similarly we have from the Microsoft also, that is Internet Information System, that is proprietary in nature, that you need to procure, you have to purchase it, not, that is not free. And similarly the one more, the latest one that is coming, Nginx, we pronounce it as Nginx. This is also open source. It also has the capability of the load balancing. Okay, so this one is very popular these days, people are using it more and more. And similarly there is Lite HTTPD, that is free and open source web server. Similarly from Sun and Java also we have it. Now which server I need to use? I told you one specific requirement over here. If you have a Java based application, then you can go for Apache Tomcat. If you have very some load balancing kinds of issues, then at that time you can go for this Nginx. Or if your users are multiple users are and the user base is very heavy, then people are going for this Nginx basically. So you can select any one based upon how well it works with the operating system and other servers. Again, that is a dependency upon the operating systems also. Its ability to handle the server side programming, how it is having those applications which are developed in different kinds of programming languages, and what are the security characteristics, the publishing search engine is available there or not, and site building capacity tools that comes along with it. Means some of these web servers, they also have certain some tools are also there which allows you to create those websites as well. So now what are the advantage of this? If we talk, having talked about all these web servers examples, we have seen it. Now let us see some examples here. Some of the advantage of the client server, like it protects the data with access control enforced by the security policies. Means all our data is secured in the server, and there we can put some access control facilities also. Who can access that data, who cannot access that data. So those features can be inbuilt. If you are keeping the data in open, then anyone can access it, anyone can use it, whatever they can do it. But if you are keeping it in a client server model, at that time you can put access mechanisms also for the data access. Similarly, it is platform agnostic. At the client end, it can be any operating system. At the server, both client and server can have different operating system. Your client is having some Windows operating system, whereas your server is having a Linux operating system. All your data application is there in Linux based system, whereas your computers, your client at the user end, it can Linux, it can be Android also sometimes, it can be a Windows operating system. Then also you are able to have a request and response system in your application basically. And it also has a large user base, can be addressed at the same time by a large number of users. Some of the limitations of the client server module is like overloading and denial of services. It is very actually occurs due to a very large number of user requests. So if your requests are reducing, and if you are putting some load balancing kind of thing, at that time these things can also be overcome, these particular. So you need to put one load balancer somewhere in your server infrastructure, so that these kind of limitations don't occur in the applications over there. Now coming to the WebGIS, having talked about the client server, where does this GIS sit into that WebGIS basically? So if you see here, again the same thing is there, like your web clients are there. It can be a web browser, thick client, other web clients, okay, and then it is a network over here. There is a firewall. This is your web server. Now this, if you see it in your previous example here, I was telling you application server. Now this application server is changing it to a geospatial server. But actually your WebGIS is nothing, it is just an application for this web environment. So we can put it, we can replace that application server by your geospatial server. So whatever GIS request will come, that will be handled by this application server, and it will pass it on to the web server, from where it will go to the client. Again, the architecture is same. It also access the data through file server. It can be a TIFF file, it can be an IMG file. From database side, if I am having the data in PostgreSQL or the PostGIS, so they are basically a spatial data handling, data management system. So there you can keep your all save files in a database management system like PostGIS. So your data becomes so secure at that, in that case, and your GIS server, geospatial server is able to fetch the data from there also. It can fetch the data from files, it can fetch the data from databases also. And once it processes all those data, then it is given to the web server, and from there to the client. So that way it goes. So if we talk about the proper definition of WebGIS, it is basically a computer software and hardware component together that allows the sharing of maps, spatial data, geographical processing operations throughout one's own network and beyond. So all the functionalities of GIS, if I am able to provide it in a network environment or in a web environment, then that comes under the category of WebGIS, and it uses some of the web communication protocols such as HTTPS or the WebSockets. These are two protocols which are used basically for sharing the for the data sharing in the web environment. So now if we talk about some of the real life examples for use of WebGIS, it can be like finding the nearest utility or the facility like restaurant, hotel, ATM, etc. from your current location, and generating online decision maps for online site suitability analysis, identifying the most appropriate options or the location for groundwater exploration. If we can do it online, that can be performed, or disseminating the spatial data product for general use like soil map, land use map, etc. We have seen in the Bhuvan Geo portal. There we have kept the data of land use, that land use map data was there. We have a demo some 2 days back also. Let me go there. Actually here, if you can see these kinds of data set, we can put it here in Bhuvan. It was there. Thematic applications, if we say. So this is actually a WebGIS environment here. This Bhuvan also. So here if I select any land use map and I am able to see Uttarakhand, let us say, and then view. So we are able to see this maps also here. This is the land use map here, along with the statistics are also here. Like built up is there, rural, and how much they are. You can just go to statistics and it will show you what is the quantifying. It will show the quantified information about this land use for the state of Uttarakhand for 2005. You can see here. Now we can also perform some small statistics, some small analysis online as well, like statistical analysis. If you see here in this particular portal, there is one option called analysis, and if I draw one small polygon in this particular site over here, and you can just see here that analyze. So it is doing online only. So what it has done, inside this polygon, what is the area of this polygon? You say that it has selected 264.871 square kilometers of area is selected. This polygon which I have drawn. So this all it has calculated online, and that to a GIS information we can say. And what it has drawn it, and then there was a map at the back, this particular land use map, and intersection of this particular boundary and land use map it has performed online, and based upon that this particular statistics is generated here. You can see cropland, it says that within this boundary your cropland is around 82.04 square kilometers deciduous forest. All whatever classes are coming inside this particular polygon, they all are displayed here. You can see here water bodies. Now let me try again. I will not take this water bodies here, draw AOI. If I click only this particular small polygon over here like this, and then if I say analyze, now you can see here that streams, and because since there is no water body inside this polygon, you can just see zero area is coming. So some just to cross verify ki how much, whether it is coming correctly or not over there. And so these kinds of information or this analysis can be performed online as well. Now I will come back to this portal for this examples basically ki how we can use it. So giving the commercial subscription. Now again, if you want to put some commercial subscription of proprietary spatial data product to various users, suppose you have a detailed GIS map of households of all the cities of a country, GIS map of household of all the cities of a country, and then you can give subscription of such data set with some price tag as well. Like you can see here, we can have a GIS portal, free GIS data set, and we can have a subscription GIS portal. Both we can have it. In free, you can have certain set of data. In subscription, again, you can have another set of data set over there. It will give you some owner's name and all those things. Here I am not giving the owner's name. Let us say in the household I am giving parcels with the PIN, owner's name and mailing address, deed acreage, assessed value, plate number, and here some more information can be given, like aerial imagery can also be given. For that particular portal, you can keep it over here. So both the modes can be free as well as subscription you can build in your GIS portal, WebGIS portal here. Now if we talk about a typical WebGIS architecture, inside the web app, that when we are talking about that WebGIS in the previous, if you see here this particular section over here, from here this geospatial server to file and to the database server, if we go here, you can just see what it basically contains, how that total things is working here. So you have this Apache Tomcat server somewhere here, or it can be any kind of web server, okay. And then I was having either geo server I can have another software is called map server, because your geospatial server is a very generic name. So and there are different alternates for that, or various tools for implementing that geospatial server. So like geo server is very popular one here, map server is another. Similarly, we have some more servers are there, it can be any. These all are the GIS servers. I have a GIS database like PostGIS. So now once the request comes from the client, now from the client end the request can come from a QGIS also, like one standalone software is there, or I can build one software or one HTML page basically, and in that HTML page we can have either you can use this leaflet or this open layers. These are certain libraries which help you to process or to generate the responses in terms of for the spatial data basically, okay. So open layer and the leaflet, two open source libraries are there. They are basically JavaScript based libraries, and they allow you to create a web map which has spatial component also, or you can also say a web GIS map you can create with the help of a leaflet or a open layer library. It will sit somewhere in your Apache Tomcat server here. That file will be there along with these two libraries, and that file will fetch the data from geo server, or it will take the data from this databases as well, and then it can be passed on further to the users. That can be a spatial request like this WMS, WFS, WCS. These are certain formats or some standards for the data access in the WebGIS environment. So these libraries are able to read these standards as well. Not only these libraries, but this QGIS. Let us see. I think I have shown you an example also how we do it in the web. This QGIS is able to access that this spatial data set. Let us take one example here. If I go here, let me check it here. Like one, let us see here QGIS here. This is your software already installed in this PCs, and I have this Bhuvan Geo portal. Now you can see here there is something called a web service. I want to access this map in my client software called QGIS. So you can see here, this is the URL for this map is given over here, http bhuvan.vec. This URL you can just copy from here, Control C, and then if I go to this QGIS, it will open up here. Yes, QGIS is open. Now here I can go to this view, and then we can have here in the layer option, basically add layer, add WMS layer, and then although I have already shown you last day demo, it was created here. Now I will just do edit here. I will edit it. Let us copy this URL over there, Control V, the same URL only. We have given some name to it, demo. We have seen this previous day also. Okay, just a repetition only. Connect. So when I am doing it a connect, what it is doing, it is going to this Bhuvan server. From there it is fetching all those layers which are available there. You can see all these are the GIS layer. There are many. Okay, and they are for different states also. You just type any state here, let us say Assam. So it will tell you these are the data set for related to Assam, like Assam or point data, or Assam, or it is at NH national highways are there, or there are many data sets which are related to Assam here, which are published in that Bhuvan Geo portal. Or let us try to type it here. Let us say Telangana, Telangana, Telangana. So I don't think that by that name anything is there, or we will see it here. We can see here AP, basically it is, I think, Andhra Pradesh, ANDHRA, Andhra. Also by that name it is not coming, but although that data sets are there, if you check it here in the portal, you can search. If you go and here you can type the, let us say I was just typing the name called by the name. If you can see here, there are many options are there. So any state you select, then it will tell you. Sometimes these names are not as per the because they had followed some particular standard, and those standards are different in this case. So so if I let me take that part only, this Uttarakhand itself, it was web service here. Now this was the name of that layer which I want it here, Control C, and then again if we go to QGIS, let me search it here. So it will tell me this is that layer, then add, and we can just close it. So it will, what it is doing, it is making a request with the Bhuvan server, and you can just see here that layer is in your QGIS platform over here. Now what has happened, basically, since this map was available as a WebGIS layer, okay, so I am able to fetch it in my QGIS software also. Now same thing can happen with your HTML page as well. You have a page, you have created your own application, and there you want this map. So what you will do in that HTML page, you will create one small application using the libraries like Leaflet, or it can be any other library like OpenLayer. These are two very popular Mapbox is another libraries, and these libraries will allow you to fetch these map from the different kinds of different servers, different GIS server. And so you can just see here, this is one map which we have just fetched from the Bhuvan server in my QGIS software. I have an example for that also. I will again come back to that. This QGIS we have seen. Similarly for OpenLayer and Leaflet, in the coming slides I will just show you how we can fetch that map through Leaflet also, and then it can be in different kinds of applications. Now how all these things is becoming possible, basically. So if you see here, there is something called Web 2.0 and Geography 2.0 I am talking. Okay. So now if we say Web 2.0 is referred as an interactive web application. Earlier what used to be there used to be some web pages, static web pages. They were able, a client was making a request to that page, and that page was getting displayed in your web browser, and there was no functionalities for interactivity from the user side. So when this interactivity came into picture, at that time it was known as Web 2.0. So this Web 2.0 enabled the interactivity of the user with those web applications or the web page. So if you can say, you are also able to participate in that in that web page, like Facebook, you are able to post something, or let us say some other social media network. There are many numerous pages are there wherein you can also participate. There is one very popular, if I give an example of OpenStreetMap. So that particular portal is allowing you public participation also. Means you can also create your own database without having much knowledge of GIS and all those things. So it is an easy to use platform is provided to you. You try to create your own GIS layer on top of that platform, and it will be sent to the server end, but it will not be available to the entire users or other users unless and until that is moderated by some specific person. At the server end also, they are also moderating it. What kind of information? It can be like that I am putting anything, any XYZ on the page, and it is getting displayed to all the people. It should not happen like that way. Only the valid, some authentic or some legal or appropriate contents only should be published over there by the from the user side. So that need to be moderated also. So that way it basically works. So that open street map, you can just remember that name. That is basically based upon this Web 2.0 concepts only. So which allows participatory information sharing, interoperability, user-centered design, and collaboration on the World Wide Web. Example, I have given you OpenStreetMap. Even in the Bhuvan also, we have seen one small polygon, we have drawn it, and we are able to access those features as well. So the integration of this web and GIS application is basically known as GeoWeb 2.0. So that way, so if we talk about the Web 2.0 and GIS, so what kind of features is it giving to us? It is giving to us as a web, as a platform. It is also applying the participatory approach. It is giving content syndication. Content syndication basically means republishing the content of a website. I have published something on my web. I have a map called land use map in Bhuvan Geo portal. Now I want to use this map in my website. Web application I have developed it. How can I use it? So this content syndication allows you to do that also. So that's why sometimes you can also see that people are creating their own independent websites wherein these news are fetched from different sources, and they represent the news in their own formats. Like one example is Make My Trip. So Make My Trip, what it is doing basically, it is syndicating the information from different airlines or different transport sources, and it is fetching it into its own portal and representing the data in their own formats. So that content syndication, it is basically the content syndication. And this there is something if the data is there in the form of a web service, I will talk more about web service also. And then these are the conceptual and the social platforms, and how we implement it. We can implement it in the Web 2.0 environment through different kinds of technical aspect, like we can have an XML format, that is RSS, that is really simple syndication here. JavaScript is available there, Ajax is available. So these all are realized, these conceptual concepts, they are realized with this particular technologies in the web environment. Okay. So there is another important concept. I was talking about this web services, very important point over here. So how does it work? Basically, we have a service provider like Bhuvan, okay, and they have created one page also, that is the service broker, wherein all those services are published. Okay, and then what we can do, this consumer as a client, what we are doing, we are searching those services. If you find it in this particular application over here, and then that service is requested from the server here over. Okay, so let us example, if you see that land use map, okay, that land use map is published by Bhuvan, and this Bhuvan server is published in entire Bhuvan is published in some in a common platform over the internet. Okay, and what I am doing, I am searching the name of that geo portal. I got it. I found out the name of the service also, and then I made a request to that server over here, and that request was, and the response was served to me in the form of a land use map. Client can be anything. It can be a browser. It can be a GIS software also. Okay, so this is now, and what the difference between a website and a web service now? So like it is both same, only it may appear like both same, but it is not so. Like now, if websites basically it provide HTML pages and forms for human user to navigate and perform the function. Okay, like searching, shopping, interaction, anything you can do it. And it has a front end user interface through the browser like google.com. They all are basically the websites. If we talk about a web service, that is not a website. Okay, operation that cannot, that can be called to the return info, to the return the information. Like you have one here, we don't have any user interface. These all are published in a website, these web services, and people are able to access them through either through not directly, not through not as an interface, but through an application like QGIS. I was able to access it. Now if you see it here, let me go into more detail of it, so that you can understand it here like this. I was having this particular URL. This is a web service basically. Control C. If I just type it over here, you can just see here like this. It will give me some XML content. Now this is basically the content here, and if we have to type some more parameters also to it, then it will give me a whole data about that land use map. But I am not able to visualize those maps in the form of a, basically in the form of a map. Okay, so what we will do now, this data is not for the common user. Basically these web services are basically for the applications like your QGIS. The same URL your QGIS is able to interpret and represent the data in its own form. So that is the basic difference between your a website and a web service. Bhuvan in itself is a website, whereas the land use map as a URL is a web service in Bhuvan website. So that way it is going. So invoked automatically through a program like QGIS, and it is publicly available and standardized for all the programmers basically, and there are examples. So when we have seen it here. So next, if we talk about that this service oriented architecture for the GIS basically. So what it does, it has different kinds. Now how we can control the GIS data in a service oriented architecture. If you see here, we can publish the data only as a portrayal service. You can only see the data. You cannot use the data for any analysis, just displaying the data. So that can be done, or so that comes under the category of portrayal services. Here we will publish them as a one of the standard of portrayal services, WMS, web map service. If you are publishing your data as a web map service, then it is available only as a JPEG file. They can see it, but they cannot utilize it with all its attributes. But if you want that users who can be, you can do it, then another concept comes, that is called a data service. So this data service, if you are publishing your data as a data service, then the entire data is available to the internet community over there, or the users who are using the internet. So it is available to them, and there is very one common format standard for it, that we call it as a web feature service. For whatever vector data is there, that can be published is a WFS, and then users can just see it there also. And similarly, there is a web coverage service also for the raster data set, like images and all those things. If you want to give them to the users, then that can also be given. Let us take one example also of web coverage service, how it is looks like basically, then you will have a better feeling of that. So there is one portal in Bhuvan. We don't have any WFS and WCS. In Bhuvan, we are only having the data as a WMS, that is a portrayal service. Okay, there is one there is a website called GeoSeer, one example website only, geoc.net. Okay, so it will just open for me. So it will just take yeah, GeoSeer for this, and then if you type here WFS for, let us say, Kerala region, KERELA, Kerala state, let us, I am just searching something. This is acting as a brokerage page for me, wherein I am searching those any kind of GIS data set. For Kerala state, nothing is there. Okay, so if I say only that, So you can see here something is available to me now, or I will say Karnataka WFS WMS for Karnataka here. So 2 or 3 it has shown it. For let me just check now, WFS plus UTTARA only an example I am showing. Okay, some mistake is there. Uttarakhand, and then if I say yes, if you can see here, village population, it is available as a web feature service. Let us try to do it here. This is the URL. It may not be available also. Controls, just copy this URL. Go to your QGIS here, layer, add layer. Now here you can see I am accessing a data service now. Layer, you can see here WFS, add WFS layer. You can, because why I am taking WFS, you can see here that layer has been published as WFS. Okay, now if I copy, I will create one new. Let us say UTTARAKHAND Uttarakhand underscore VIL. Some name I have given, or WFS I will give. WFS, something name I am giving. I am typing that URL over there, and then I am saying OK. It is connected. Now just click on this point here, collect. So it is giving some error here. Since you can see here that is download the capability failed, error transferring. So it is URL is not able to that the possible reason is that server is not available for me. Since now you can see here this is the HTTP only. Now these things have been stopped. So this is one new server is there, HTTPS server. So let us try to take this particular server now, or we can say here there are many, because these all are WMS only. So WFS, like let me check it here if any WFS is there. You can just check it here. It is all showing WMS only here. WMS, although it is written here WFS, but this all the in the service you can just check it here, service equal to WFS. Okay, so it is not available to me like that here. Let me check it here again, then Control C. We will try to change it here, layer, and then add layer, add WFS here, and let me edit it. Let us change this, the URL from there. It is HTTPS now. Okay, and service equal to WFS. I will change it here. We can change it like this. Let us try to connect it here, and then if I connect it, it is also not making certificate error it is giving. So this what I will show you, why I showed you over here, because because this is all dependent upon the other end, whether that feature has been available to you, or you can say here some restrictions might have been put over there. So anyway, but we can have the data in that format also. You can search it further. There may be some other servers here, like it was AIT server, or there are some other servers also which will allow you this WFS kind of things. As only WFS, if you type it here, it will show you a list of all those maps here, like this. Let me take now this one here. Another server is there, land cover surface WFS. Let us try to take this particular server now, layer, add layer. I will say WFS layer here, edit it. I will change the server name from this, Control V, and then I will click OK, and let us try to connect it. Yes, this one is making a connection, means this server is having a valid data content at the other end, at the server end. So it is able, now it is currently it is not giving an error. It means it is trying to make a connection with that server basically. So that name of the server was something msdi.data.gov.mt / geo server, and something is there. Okay, so this it can take some time also, again depending upon the availability of the server over there at the other end. It again all depends upon that case also. So the crux was that we can publish the GIS data as a web feature service as well as a coverage service, also as a data service basically. Or sometimes if you have some algorithm and you want that algorithm also to be published as a service, so that can also be done. That is done through processing services. So very common format is WPS, web processing services, and so I told about portrayal services, processing services, data services. Now encoding services also. You have a land use map. It has some different types of colors are there. Yellow color for your agriculture. Similarly, green color is for your forest, or red color is for the settlement. So these all color coding of those features can be done with the help of certain encodes. So we call them as slide, that is style layer descriptor. SLD format is there. So that is a very common format called SLD. So you can publish your symbology or the scheme or the color scheme of the layers as a SLD, and then it can be published as a service over here, and then it can be utilized with those data service or any portrayal service, anything you can utilize it with that things also. Okay, so then there is a catalog service also. You can publish all the data set as a catalog, and it will be available. And then this client, they all these services are available for they are available for the accessibility, means user can find it, you can search them, they are searchable also. You can search it, and then at various, it can be a client can discover it. Map viewer clients are there, imagery exploitation clients are there, value added clients, so, or sensor web element clients are there, symbol management clients, many clients, it can be anything, any user. Okay, multi-source integrated application clients are there, they can all utilize it. I will show you one example also. There we have tried to use the data from different sources. So now these days, although these are not theoretical, people have used it, and they are full GIS servers are now emerging. They are providing the centralized GIS services. We can say open in the open platform, or the standard web services like map visualization, or the data services, editing, geoprocessing, cataloging. So there are certain XML standards for that. They all are being developed, and they are being made available as a centralized and distributed GIS development platform. Example, if I take one example, we have created at IRS also here, that is forest fire platform we have created here, you can just see. So here what we are doing, we are trying to publish the data, we are trying to disseminate the fire alert for the state of Uttarakhand, basically here in an online mode over here. You can see what we are doing here. You can see one fire map if I talk here. So daily this particular map is generated, and it is displayed in this portal. It is available over here, and it can be visualized. It is a daily map which is created at the back end, and it is published in this platform. Okay, this is one map which is done locally, okay, locally in the IRS. Now apart from that, there are some other map informations also, like VIAR 24-hour latest forest fire. This is coming from some other portal. This we are not developing. Now you can see lots of fire points are visible over here. That may be the reason of that crop burning maybe. Okay, so that's why it is giving like this. This kind of information you can see here in the entire state. It is giving in Uttarakhand here also. It is going some at some of the places like this. So this is one information. 48-hour information also it is available like this. This is coming from some different portal now. And now this is forest fire risk zone that we have created at IRS and published it as a service. We are able to see it here, and this is one satellite image also that can be published here. And you can see some weather information also. We have another portal called MOSDEC from there. From there, we are able to fetch the data into this portal. If I click on this MOSDEC here, and I want to know the data at this point here, you click at this point, it will tell you the weather information for that point. Let me go to any one specific area over here. Let us say Dehradun region here, and I want to know the temperature, humidity and rainfall at this point here. So if I am clicking here, it will tell me there is 0 rainfall. The rainfall can be removed from here, and the humidity is also at this level 50, and it is going up to from 0 to 50 from, and it is forecasting also up to 5th of November it is giving. Now this all data is getting fetched from MOSDEC. Similarly, day before yesterday, I also told you about one of the weather information, one portal about called Open Weather Map. So that also we have integrated into this portal. If we talk about the Open Weather Map, and here I will just type the city DHRADUN Dehradun, then it will fetch it. It will go to open weather map and it will fetch that data for me, and that will be displayed over here. So if you click it here, yeah, it is showing here. It has zoomed to that place, and you can just see here. This is Dehradun city, and here 26-degree temperature, feels like 26, 45, and here it is also giving the forecast for the further data set. So these all are inbuilt into a common platform here, into forest file, because these are all are associated information. Now if I again go to weather information here, and then we can go back to the places, to our main website over here, weather info, and it is so if I just refresh the page, so now let us try to take it for some other city. Let us try to take another city, Kochi, Kochi, Kochi or something. Okay, Kochi, and then it will tell that it will zoom to that Kochi region over here, and it is saying the temperature is going something 33 degrees Celsius and feels like 40 here. It is quite high temperature over here. Forecast also it will give like this. For any city, you type it there and it will provide you the data. So the data is now available in two formats, we can see. It is, one is from the open weather map and other was from the MOSDAQ. So both are inbuilt into it. So that, and another thing is, one more we will see here. So there is Bhuvan map. So we have, what we have done, we have tried to take this Bhuvan satellite imagery also. You can see another, now this map is coming from that, this satellite image is coming from the Bhuvan Geo portal, the entire satellite image. We can also have it from Bing map, we can have OSM OpenStreetMap also. So all these can be inbuilt, integrated into a single platform if you are having the clear concepts of WebGIS basically here. So this we have done it here now. Now these are some of the quickly I will tell now. WebGIS server component, it have a database. This already I have covered up. Database server was there. I told earlier there is a map server also, or we can also call it a GIS server, which will take the data from this database, and we can have an application server, and then at the end we have a web server also. So if you take an example of a WebGIS service, we have already sent. It is a service that is self-contained. It is self-described also. It is modular component of geospatial application, which can be accessed through the standard protocols like HTTPS. So through that it can be accessed, and to be more specific, if we talk, it is a piece of code that runs on the server and can perform some of the actions in response to the client request. Example, if we take, we have seen one example basically, when we draw one polygon and there was a land use map, and it was able to extract that land use statistics for me. So that is one example there. Some of the important considerations for web services is like, for issuing the request and receiving the response, we have format like XML or the JSON. Protocols are HTTPS, or this is now depreciated HTTP. So mostly people are using HTTP, and there is one portal, there is one global consortium called OGC, Open Geospatial Consortium, which is basically developing all the standards for GIS. Like it can be a WPS, it can be a WMS, WCS, WFS. All these are developed by this particular consortium, and they have been in a standardized form. So many proprietary software, they are also adopting to these standards, and they are very much compatible for these standards developed by OGC. So it is a world where everyone benefits from the geographic information and services made available across any network, platform or application. So this catalog, already I have told about different kinds of catalog processing and the encoding services, data services, portrayal services, and other services like. Now some of the WebGIS servers, if we talk, there is one software called Geo Server. It acts as a WebGIS. This is open source in nature. Similarly, UMN Map Server is again an open source WebGIS server. ISRI and Apollo, they are the proprietary software. ISRI ArcGIS server is from ISRI company, from the proprietary item of ArcGIS, and this Apollo server is basically from the Aradas Imagine. We also call it Hexagon Limited. So for that platform we have another proprietary software here. Now for the web mapping libraries or leaflet, and apart from OpenLayer and leaflet, we have D3, Polymap and Modest Map. These are certain libraries which allows you to consume those web services which are in the GIS from the which are from the GIS domain basically. So I will just will quickly go to this particular leaflet example here. Now here we can develop one small code also. If I see one example, I just wanted to show you here. This is one HTML page which we have created. Control C. I will just tell you here, notepad. And then if you are creating it like this, you can see here there are some standard libraries. You need not to remember it. This is the link for the leaflet. Online link is there. I am referring it over here, and similarly I am referring the style or the script of the leaflet till here. Just copy paste from internet and paste it over here, and then then we have this script here. Since I have already imported leaflet over here, then I can use the methods of leaflet in my portal here. So I am creating one variable called my map. I am giving it some ID, and then I am calling this Bhuvan layer from the internet. Okay, that we have just seen through QGIS. We have seen it, the same name of the server, and then name of the layer, and then some more parameters, and then I am adding it to my web page. Let us try to see it here. If I see it here, save. I will share these slides with you so that you can also practice with this particular code for consuming different kinds of web services. So I will say here, let us say demo, demo.html, and I will save it here like save, and then once it is saved, you can just see here. Okay, it has also connection failed here in QGIS. So now demo, if you just right click it here and open it in your browser, let us say Google Chrome, so you can just see that map is in your browser. One web page I have created, and I am able to fetch that particular map in my web page. Now this web page can be changed here, like anything. If you can change it web page like this, let us say I will put something in the body also here. I will put it here like some name I am giving here, H1 heading I am giving. H1, this is my page. Now I am customizing it. My first web GIS page, my first web GIS page, H1. Okay, and then if I say Control S, I am saving it here. Just refresh your page. So it will, I will just save it here again. I think it is not saved. H1 here, and again I will copy from here, Control X, and I will put it over here basically. Control S, and then F5 we put it here. So it will give me, just go up, and then you can see like this, my first web page, something we have written here, and this is your page. We can center it also. There are certain codes for this also. If you just put it here like CENTRE, center, okay, or ER, sorry, center, and then we can just make it here like center, close it, then Control S if I do, and then F5, so it will come to the center, and now you can see like this. So just mean to say that I can customize these layers in different formats basically. So I can have my own page, I can have own maps from different layers, I can have OpenStreetMaps also at the back of it, or I can create two pages. You can see here, we can, just like in the forest fire we have seen it. It is again depending upon the that how much creative you are, how much creatively you can create your web page, and just put like some banners we can put, some layer list we can put it over here. So these all are possible if you are having a good idea of this WebGIS platform. So I hope that you will be practicing more and more toward this WebGIS. More interest you should generate for this WebGIS platform, and try to explore the things from the WebGIS perspective. Okay, so that's it, and thank you very much.